Okay. Looks like we've got a coffee networking social coming up as well, but here I'm introducing a session that's really something that's really near and dear to my heart. My name is Dominic Del Molino, and I'm the Vice President of Field Technology and Engineering for Amazon Web Services, Worldwide Public Sector. One of the things I get a privilege to do is interact deeply with some of our customers who have supremely critical mission requirements. And some of my customers I get to work with, they have kind of busy seasons, right? The Christmas season where they're trying to respond to retail packaging or shipping. I have other customers that have tax season where they get prepared for a large-scale event that's going to occur. So some of these customers can plan around some of their busy seasons. But I've had the opportunity and privilege to work with the Associated Press, and with news, there is no quiet season. Any day at any point in time can be the busiest season of the year. An event that occurs around the world where AP is at the front lines, reporting the news, making it available, not only on their main website, but across all of their partners so that the citizens of the world can stay informed about what's happening. The Associated Press can't go down. And so they need a resilient architecture that continues to stay up and running through some of the largest events and the largest amount of traffic that occurs when these breaking news events happen. And so we've partnered with the Associated Press to help them build a resilient architecture that allows them to keep running, to allows them to scale when these major events occur. And it's my privilege to introduce Akshay and Chad, who are going to talk to you about how we've gone on that journey together as a partner with the Associated Press to help them build a resilient architecture so we all can get the news when we need it.
Thanks a lot, Dom, for the introduction. Hi, everyone. Welcome to this session where we will learn how the Associated Press fortified their news pipeline so that it can be resilient to large-scale events in AWS regions. Many organizations like AP, I'm sure many of you here are running your mission-critical applications on AWS. Now, while designing and building these applications, we often are focused on performance, adding features, leveraging cloud-native capabilities. Very often, resilience or multi-region disaster recovery is something that doesn't come into the conversation until you're hit by a large-scale event in a region and your mission-critical application or workload is down. At AWS, we have built a number of services, best practices, strategies, and patterns that the Associated Press has implemented to make their media platform more resilient. And we will talk about a lot of these practices during today's session. My name is Akshay Saxena. I am a solution architect leader supporting nonprofit organizations running their mission-critical solutions on AWS, helping them design, build, and operate resilient workloads on AWS. Let's walk through what we're going to talk about today. All right. Many of us have heard from our Amazon CTO, Werner Vogels, that it is important to build systems assuming that everything fails all the time. What does this mean, right? As organizations have grown complex, so have the systems that you build, getting more and more complex, multiple microservices, a lot of dependencies. Things can go wrong at many different levels. Things can go wrong at the process boundary, application level, network level, configuration level. Issues can hit you, where they haven't hit you before. So resilience is all about your plan. Resilience is all about planning for what happens when you have that bad day, when you're hit at the application, network, or configuration level. When talking about being hit, having downtime is one of the first side effects of your application being down, right? And downtime is expensive. Some ways that downtime can hit your organizations are pretty obvious, as we can see here, but nonetheless very, very important to consider. Let's look at the first one, revenue. If your mission-critical application is down, you are not able to sell your services or your products, and it's a direct loss of revenue. Number two, brand. Your users are used to a seamless experience when utilizing your mission-critical solutions. When they're not able to access those solutions due to downtime, they will be pushed towards your competitors and other similar services. And this can also lead to some significant reputational damage. Number 3, productivity, not to forget. When your applications or workloads are down due to a large-scale event, your internal staff is taken away from the regular day-to-day job and are focused, all hands on deck, trying to figure out the solution. This downtime actually has additional knock-on effects and in other parts of your business and impacts productivity. Right? Last but not the least, regulatory concerns. Many organizations have regulatory requirements that require certain uptime. And if those uptime requirements are not met, there are financial penalties that they have to go through. So as you can see, downtime can be expensive in many different ways. It's not just purely about dollars or revenue. It can be productivity, brand recognition, and of course, regulatory requirements. Now, I've been saying a lot of, resilience is about planning for a bad day, but let's define, what is resilience. And this is how we define resilience according to the well-architected framework. Resilience is the ability of a workload to recover from infrastructure or service disruptions, dynamically acquiring compute resources, and also mitigating disruptions such as misconfigurations, transient network issues. You can see the focus here is not just on application-level issues, right? It is about infrastructure issues, about configuration challenges, network issues. So really, it's all about building the ability in your workload to recover from these disruptions. Because as Werner Vogel said, everything fails all the time, and we need to plan around that. We have all heard about the shared responsibility model on AWS, right? So resilience is also a shared responsibility between AWS and you. So it is important that you understand how disaster recovery and availability that are part of resilience operate under the shared model. So resilience of the cloud is AWS responsibility, while resilience of your workloads running in the cloud is your responsibility. You're like, what does this mean? Let's dive a little deeper into this and try to understand what really the shared responsibility model means. Now, AWS is responsible for the resilience of the infrastructure that runs all the services that are offered by the AWS cloud. The infrastructure comprises the hardware, the software, networking that runs the AWS cloud services. At AWS, we make every commercially reasonable effort to make sure these AWS cloud services that you're using are available, ensuring that they meet or exceed the established service level agreements, or the AWS SLAs. Now, your responsibility when it comes to resilience is really driven by the AWS cloud services that you select. What does that mean? Right? Let's look at this with some examples. Let's say you are using a service such as Amazon Elastic Cloud Compute, or EC2. It requires you to perform all the recovery resiliency configuration and management tasks. So when you deploy an Amazon EC2 instance, you are responsible for making sure that it's deployed across multiple availability zones within a region. You are responsible for implementing self-healing through mechanisms such as auto-scaling group and using resilient workload architecture best practices for all the applications that are installed on the instances, right? Now, let's look at another type of service, more managed service like Amazon S3 or Amazon DynamoDB. This is where AWS operates the infrastructure layer, the operating system, and the platform. And you, as customers, are basically accessing the endpoints to store and retrieve data from these services, right? In this scenario, you are responsible for managing the resiliency of your data, including backup, replication strategies, and versioning, while the service resiliency is managed by AWS. So this is kind of how we look at the shared responsibility model for resilience when running your workloads on AWS. Now, this is a really important question that I often get from customers like you. Many customers ask us, do I have to be deployed across multiple regions to be resilient? Let's dive a little deeper into that. And for that, we need to take a step back, right? Let's look at what an AWS region is. An AWS region is resilient by design. When you're using the AWS region, you benefit from 3 availability zones, where each availability zone is separated by a meaningful physical distance from other availability zone. Each availability zone consists of 1 or more discrete data centers. So when we at AWS build availability zone or AZs, we take into account things like separate power substations, floodplains, fault lines to minimize the risk, right? And because each AZ is located in a separate physical building, separated by a meaningful distance from others within the same region, the fate of one data center, for example, a data center got flooded, won't affect other availability zones in a region, right? So you can clearly see that the AWS region by itself is built of multiple AZs, which are resilient by design. Now, obviously, if you're still in the decision phase of trying to figure out, should I go multi-region or not? It's, again, really important to remember that AWS regions are built to be highly resilient, and not every workload needs to be multi-region. We will learn about the Associate Press journey and their decision as to why they went multi-region. But I want to call out that it is not always the answer. In fact, I encourage you to ask yourself the question, is your workload following the AWS well-architected framework best practices and benefiting from the resilient design of AWS regions? Because if you're not well-architected in a single region, then going multi-region isn't going to help. It could actually make it way worse because of increasing dependencies, operational costs across multiple regions, which can be a nightmare if you're not architected properly in a single region. Well, I spoke a lot about why multi-region is necessary, but we do at AWS provide specific guidance on what are the different multi-region strategies for disaster recovery. If multi-region is the right answer for you, there are these 4 approaches that you can take for building your multi-region workload on AWS. You can see these 4 strategies are really driven by 2 things. RTO, which is recovery time objective, that is how long can you afford to be downtime. And number 2 is RPO, recovery point objective, that is how much data loss can you tolerate. And from left to right, these strategies really are depend. You can see it goes from a few hours for RTO and RPO all the way to almost near real time and near 0 data loss. Let's start with the first approach, backup and restore, right? This is typically a suitable approach for mitigating against data loss or corruption for low-risk use cases. You typically have an RTO and RPO of a few hours, and the approach is really as simple as just take a backup of all your data in another region. And when an event occurs, you restore from the backups, spin up your compute and other supporting resources that are part of your workload. Hence the RTO and RPO for a few hours, because you probably will be down for a few hours. Now, if that approach is too risky for your workload, you can consider something called the pilot light approach. With pilot light approach, you actually replicate your data from one region to another and provision a copy of your core workload infrastructure, right? So think about you have a database, you've replicated the database, it's running in both a primary region and a secondary region, but your compute is just turned off. And when an event occurs, you provision your compute and other resources before your application or workload can start taking traffic in the secondary region. That's the pilot light approach. The third approach is called warm standby. Warm standby is actually an extension of the pilot light approach, but it basically contains a fully functional copy of your production environment in another region, but at a much smaller scale. So if you're aware, let's say if you're running an EC2-based workload, your auto-scaling group would be really small in the secondary region, and then it would scale out after an event, right? This approach kind of extends the pilot light and just decreases the time to recovery because you have a smaller copy of your workload always live in the secondary region, right? The last approach is also the least RPO and RTO approach, and obviously the most complex and costly approach, which is active-active, which can also be used in an active-passive way, is having your workload deployed across 2 regions having the ability to take on full production level traffic on both the regions. You can actually operate this in an active way using something like geolocation routing and moving your traffic to specific regions based on your user's location. Or you can also have this as an active passive and only have flip over based on health checks to the secondary region. But in the last scenario, you have basically a replicated architecture that you have in the primary region in the secondary region. So these are 4 real approaches that we have for multi-region disaster recovery available to you at AWS. Now, we spoke a lot about resilience and disaster recovery. But I really wanted to bring focus back on what we want you to take away from this session today. Right? We will explore in subsequent slides how AP's experience led to these 3 takeaways. But I really wanted to first put these three takeaways in front of you. Number 1 is app modernization innovation accelerates beyond lift and shift. We'll see how AP started with a lift and shift, modernized their application, and then made it resilient, and how it's lift and shift is just the start of the journey. Multi-region requires careful evaluation. I touched on this a few slides earlier. Not every workload needs to be multi-region. You will add unnecessary operational complexity if it is not a super critical workload. Number 3 is aggressively pursue simplicity. We'll look at some of the patterns that AP adopted and customized for their needs. And really, you'll see how simple they are, but with few tweaks, fit their specific architecture. I will now hand it over to Chad, who will take us through AP's resilience journey.
Thank you, Akshay. This is my 5th reInvent. And some of the sessions that I remember best are actually customer sessions. But they're the ones where the customers get past all the celebrations of their cloud triumphs, and they talk about real things. And to me, real things, well, that's pain. And those are the lessons that you learn in your journey. So that's my guide here today. I'm going to share a little bit of our pain. I'm going to share some of the lessons that we've learned, and hopefully you find it useful in your journey. My name is Chad Shore. I'm responsible for software engineering at the Associated Press. What you see up here, what you see behind me, this is why I do what I do. The AP is one of the most trusted sources of fast, accurate, objective news in the world. And this mission and this reach, it's why I get up every day and go to work. The AP has been a leader in the news industry since it was born in 1846. My goal is to help keep AP in that leadership position in this world filled with uncertainty and change. Now, if you've been around for 178 years, you got to have a cool origin story. Here's ours. In early 1846, a war breaks out between the United States and Mexico. This is down by Texas. It was a border dispute. And this was very much the compelling news of the day, especially in the biggest market in the US, New York City. Now, the 5 major papers in New York, they were scrambling to cover this war. This type of coverage, really expensive, it's just so far away. So the publisher of one of these papers, the New York Sun, is a guy by the name of Moses Yale Beach. And he sets up this system. He gets news dispatches off the boats in the Gulf of Mexico. He puts them on the Pony Express to race north. From there, the news gets on stagecoaches to race further north. And we're going to hit the southernmost telegraph point. Now, the telegraph was just invented 2 years prior, 1844. So we've got news dispatches crossing the Gulf by boat, onto the ponies, to the stagecoaches, into the telegraph. This whole thing costs a fortune. So Beach proposes to the other 4 newspapers. He says, look, you guys share in the cost of the setup. You can share in the news coming out of the other end. And that's the beginning of the Associated Press. From the ponies to the stagecoaches to the telegraph to today, 2024, here is a snapshot of the AP business today. And beyond what we're most known for, right, coverage of breaking news in a variety of different formats, customers also come to us to search through our archives. and find that historical content that meets their needs. AP journalism has been recognized by many awards over the years, including 59 Pulitzer Prizes. And just this year, we won our first Oscar. This was for a movie called 20 Days in Mariupol. We're a news organization, but we've played this important role in the news industry as a technology leader, taking cutting-edge technologies and applying them to the processing, creation, and distribution of news. In 1920, we were part of the very first live election coverage. We partnered up with the Pittsburgh Post and station KDKA. And we took our live election results and we read them over the radio for the first time in history. In the 1970s, early 70s, we flipped our whole editorial operation to use computers to write, edit, publish the news. And the news was distributed over the teletype machine. Later that decade, we introduced the first laser scanning network for photos. And in the 1980s, we built the first satellite distribution system for news. And that revolutionized how photos were distributed. You guys might have noticed this year the course catalog is pretty AI heavy. Well, the AP was using AI in our newsroom 10 years ago, in 2014, to help us write stories, generate stories about corporate earnings reports. There is a pattern here. Technology and innovation, it's an important part of who we are as a company. That's one of the reasons why I'm proud to be standing here talking about our journey to the cloud and our partnership with AWS. All right, so we know a little bit about AP as the company. Let's talk about AP technology. We have a platform. It's mostly custom built. It runs in AWS, but what does it actually do? Well, it starts in the field. And what's the field? Well, it's not the office. The office for our journalists is quite literally the surface of the planet. Sometimes above it, sometimes below it, but where the news is, that's where our people are. And it could be in a stadium, covering a game and writing up a game recap. It could be taking photos of a protest. It could be taking a live video feed of a political speech. Or sometimes it's putting on a helmet, putting on a flak jacket, and covering what's happening in a conflict. Let's take an example of a recent newsworthy event, and I'm going to talk you through what the AP technology platform is doing. You are a photographer. You're at the 2024 Olympics in Paris, and you are assigned to cover the women's soccer final. You're in the stadium, Parc des Princes, you're on the sidelines, and you're taking photos of the match. And you have a wireless-enabled camera and some kit that's going to transmit your photos as soon as you take them to all of our editors to work on those photos. As you will see soon, the AP tech platform, using technologies like CloudFront, S3 events, SQS, SNS, we're going to be distributing those photos all around the world for editors to see instantly, whether they're in our makeshift operation in Paris or anywhere in the world. You take a burst of photos. Turns out it happens to be the game-winning goal by Mallory Swanson. The editors responsible for this soccer game, they're going to be using a custom-built photo editing tool, and they're going to be viewing your take, these photos, choosing the very best ones, applying some light metadata, and publishing them to the world. That application runs in AWS. It's a small Angular front end, and it's connected to a suite of microservices in the back end that are going to handle the processing of your photo. Our microservices follow a pretty standard serverless pattern from AWS. So we're fronted here by regional API gateway endpoints. We implement the services in Lambda. We use S3 for durable storage, and SQS and SNS for integration with the rest of the platform. Our integration approach is largely through events. So using S3 events, SNS, SQS, we've effectively built a serverless pub-sub message bus. So this is an old school classic computer science pattern. We've just implemented it using newer services from Amazon. So one of the services here that's subscribed to the bus might pick up your photo, hydrate it with descriptive metadata, and publish it back to the bus for other services to then do their work. The published story, your photo, other content, we make that available to our customers through our web portal and our media API. And then you guys, the public, the news readers, you'll go to apnews.com or download the AP mobile app on your phone, and you can read through the recap and see all the photos. If you want to see news from one of the most trusted organizations in the world, go to apnews.com, download AP Mobile. I think you're really going to like them. About 12 years ago, we started coming around to this idea that unless your R&D budget is in the billions of dollars, owning and operating your own data centers, it hinders your business's ability to be innovative and fast. It wasn't really openly discussed, but when your company has to make these huge upfront purchases just to get a project off the ground, you, as an engineer, your whole solution design lives in the shadow of those purchases. So you better hope the assumptions that you were making on day zero of that project, they were good ones. We knew we needed to move to the cloud. We needed to shut down the data center. We needed to change the financial model of how we work, of how we build and how we operate. And we did that. We moved our systems to AWS. Most of the work was taking workloads that ran in our building, applying some deployment automation, and then running them in AWS. So servers moved to instances. And we celebrated. And after the celebration, we were left feeling like, well, what's the catch? You see, our costs didn't go down by that much. And for some systems, they actually went up. And some of those issues that we had when we could physically see our servers in our building, well, we still had them. To a lesser extent, but they were still there. We offloaded some of the management burden of operating servers, but now we're in the business of operating instances. And we come to this realization. Lifting and shifting systems that were designed to run on servers, it can only take you so far. Refactoring, and in some cases rewriting to be cloud native, that's how you take advantage of the scale and the capability that AWS has to offer. That realization, that begins our serverless journey in earnest. And we start building some serverless workloads. And guess what happens? Our costs, they go down. Our capabilities increase. Those management burdens of babysitting instances, they go down. Our service issues go up. So the costs go down, management burdens go down, and our service issues increase. And we come to our next big realization. To achieve high availability that met our SLA with our new serverless implementations, well, to do that, we had to go multi-region. You see, as our footprint of serverless implementations increased, this new awareness about AWS starts dawning on us. We were coming from this multi-AZ background. That was our school of thought, right? So it wasn't a question of whether we would use, everything was EC2 based that we built. So it wasn't that we would use multiple AZs, it was what did that business require? How many AZs would we use? Our serverless implementations, they actually increased our exposure to AWS service issues. So we start becoming more in tune to issues in AWS. And we have a few observations. Again, these are our observations. The first one is that hardware was less likely the root cause of an issue. We saw more problems caused by software changes. Frankly, that's not a surprise. We see the exact same thing with our own platform. We see the same thing with the other vendors, the other providers, the other services that we work with. And as a contrast to EC2, services within a region have a higher degree of interconnectivity, especially those low-level foundational services. So you might see one service starting to degrade a little bit, and then other services then tipping over. The third observation we had was that software-oriented outages tended to be longer than hardware-oriented outages. And from these observations comes this idea, and ultimately our architectural direction now, that we need to run all of our critical workloads in a minimum of 2 regions in AWS. That might seem like a no-brainer for AP, especially the tidy way that I just laid it out there. But the decision to go multi-region is one that needs to be carefully weighed company by company. These are just a few highlights of the checklist that we used. If you're running across multiple regions, you're going to be dealing with replicating your data in some form. I don't see any way around that. So what is your tolerance for replication latency? What is your tolerance for replication inconsistency? You need to start paying very close attention to those consistency models of the data storage services you're planning on using, and make sure that they align to the business needs that you're trying to service. Like if you're not okay with eventual consistency, you need strong or commit level consistency, you might have to introduce a coupling between regions to achieve that consistency. And anytime you have a coupling between regions, you can run into a little bit of trouble. Amazon themselves, they say when they build a region, they build it to be completely independent and isolated from other regions. I think that's smart. I think you should use the same thinking in your solution design. The last point here is about the maturity of your development process. Right? If your plan is, if you're not going to do this from the beginning of your projects, and your whole strategy is, I'm going to back into this later on down the line, there's a chance that you might struggle a lot. It might not even work. So what do I mean by this? What does building into regions mean? Most importantly to me, it means addressing the hard part about being multi-region in your original solution design. Hint, the hard part's replication. It also means running your development environment in 2 regions. It means building your CI/CD pipelines to deploy in 2 regions from the first sprint. It means testing in 2 regions. When you have a multi-region solution, data replication at some level is unavoidable. But be careful. Danger lies ahead. It's my humble opinion that your data replication strategy is the thing that will tank your multi-region solution if it's too complex or if it's unmanageable. Let's take the easiest possible case here, right? You only have one single set of business critical data that you need to replicate. So you replicate that one set of data once, okay, you're in business, go forth and prosper. But if you take that one set of data and you replicate it twice in 2 different places, that's just not twice as hard. That's an exponential jump. You now have to manage data inconsistencies of the same data set in multiple places. Our first attempt at replicating our data corpus, and that's AP content, we tried to follow the principles of keep it simple. And the easiest thing that we thought we could do was to use S3 events and cross-region replication. We quickly learned the SLA for cross-region replication did not meet our replication latency tolerance. So that SLA, you can look it up. It's along the lines of 99% of your data will be replicated in minutes, 4 nines within 15 minutes. Didn't meet our latency tolerance. That's okay. Actually, I think this was smart. We tried the easiest thing first, and it didn't work. Here's how we solved the latency issues. We emulated S3 events with our own software. Our technology platform uses the single writer principle to push content into our S3 bucket. So that process knows exactly when a particular object is created or when it's been updated. And at that moment, it can raise an event, effectively emulating what S3 is doing. And we've observed our emulated events are a little bit faster than the ones default out of S3. Now for the bigger one, the cross-region replication latency. We knew that DynamoDB global table replication was significantly faster than that cross-region SLA. We're not using DynamoDB to replicate large binaries. That is squarely in the wheelhouse of S3. But for small objects and text files and metadata blocks, those things replicate in milliseconds, not seconds, not minutes. We're using the AWS replication approach here, but just with a different implementation that met our replication latency tolerance. A classic software engineering enigma is, how do I know if my application is healthy? If that weren't tricky enough, how do I know if a region in AWS that could be running any number of my applications, how do I know if that's healthy? This is a pattern that we use. It is in line with Amazon architectural recommendations. The goal here is providing a fast, accurate answer to what can sometimes be a pretty tricky question. Our applications around the world call a regional endpoint, a health check endpoint, to learn what the closest geolocated healthy region is. And this endpoint in turn returns information about that closest geolocated region. Things like the Cognito endpoint for that region and other info that those apps need to run. Now behind the health check, there is a fleet of application-aware Lambdas who are responsible for checking the health of their individual systems. We aggregate all of this information into a file in S3. We got into trouble here with our first implementation of this. Our health check would call, even in parallel, would call all the app-specific Lambdas directly. And as the number of consumer apps that we had grew all around the world, as the number of health checks grew that we were, in the fleet of Lambdas, performance started suffering. We started seeing timeouts. We started bumping into API gateway limits. This solution was missing a pretty basic level of abstraction. Interrogating a file in S3, looking up a row in a DynamoDB table, it's so much faster and so less error prone than trying to call a lot of Lambdas, even in parallel, all at once. This is an endpoint that you're going to be calling a lot. So you want it to be accurate, but you need it to be blazing fast. You ever see this message before? We are investigating increased error rates. I think it's pretty unlikely that there's going to be some catastrophic outage that's just going to tip over an entire region. And you know what? In that case, you've got your health checks. They'll take care of automatically shifting your traffic over to the other region or regions that you support. I think it's much more likely that you're going to see some level of disruption to a service. So this is not really an outage per se, but it introduces enough instability where you now need to make a decision. I'll give you an example. If Lambda is having elevated API error rates in one of the regions that we're in, we're on the phone assessing the situation, and we might move our users off of it. So what might be this informational notice for Amazon, for us, is this is an unstable region, we're going to move. This is the case of proactively moving traffic. And we use global DNS manipulation to do that, just pointing from one regional API gateway endpoint to another. Amazon's guidance here is this: do not depend on the control plane for outage remediation or outage recovery. And we have been bitten by this one. There was an outage a few years back in US East 1 that affected the control plane. Our global DNS was being managed in Route 53. So those administrative commands that we needed to move traffic, well, they depend on the control plane. We could not issue them, and we were having a service outage. Our solution to that problem was to pull global DNS out to another provider. Amazon's got articles. You can go check them out with other solutions that resolve that control plane dependency issue. This is the one that we felt most comfortable with. I keep mentioning we're using recommendations and design patterns from AWS in our solutions. You should too. How closely you follow them, that's a decision that you need to make. But you should at least know what the patterns and the guidance from AWS is and factor that into your designs. So I'm going to hand it back over to Akshay, and he's going to tell you about more AWS services and more patterns that you can use to make your apps run across multiple regions.
Right, thanks a lot, Chad, for sharing AP's resilience journey. That is truly inspiring. So Chad mentioned about some strategies, patterns, best practice that AWS has published around resilience. And I'm going to take the next remainder of this session to actually talk through some of these best practices, strategies, and also talk about some service that will help you implement these patterns. So as part of your responsibility for resilience in the cloud, you really need to think about how things could go wrong. And at AWS, we classify categories of failures into these 5 broad categories, right? And you can use this as a framework for building resilience workloads on AWS. What you want to do is brainstorm these categories and then figure out, mitigations that you can create and whether you have the observability to detect them. You'll also need to weigh the cost and the business impact to determine if the mitigation is worthwhile for your workload, right? Let's take an example. A code and config failure, something like bad code being pushed or an expired credential. I guess that's never happened to anybody ever. But what happens when you have something like that happen? Do you have the right instrumentation to detect it? Do your CI/CD system, can it automatically do a rollback? That's a mitigation that you want to put in place. Similarly, putting mitigations in place for what if an instance goes down, or my database becomes corrupt, or one of my third-party payment APIs is not working. So it's all, you need to really look at your failures across these categories and also think about the highly unlikely scenario of all of internet failure of California going into the ocean due to the earthquake. Now, to kind of put this all together and get you into the resilience mode of thinking, we have the resilience mental model. Right? We define resilience as the ability of a workload to recover. But this resilience mental model is what I want you to consider when you're designing a resilient workload on AWS. It has 3 components. Number 1 is how you can build highly available systems with resistance to common failure modes. We looked at those categories of failure. So you really want to build a system so that it's highly available and able to mitigate itself from common failure modes like code, bad deployments, instance termination, etc. You need to figure out how to recover your system if you run into those rare failure scenarios. And that's through strategies such as backup recovery, data bunkering, and so on. And finally, I think the notion of continuous improvement. Resilience is not a one-time thing that you just check off your list. Continuous improvement entails things like implementing automation in your DevOps pipeline and practices, introducing failures in your system to check the resilience and strength of your system, and continuously improving your architecture. And this is something that AP has been doing really well over the last few years. We saw AP implement a lot of these principles as they modelize their supply chain platform. Chad mentioned the concept of control plane and data plane operations. Let me touch and dive into this a little deeper. Right? Control planes at AWS services basically have 2 types of operations: control plane operations and data plane operations. Control plane basically provides the APIs for CRUDL operations: create, read, update, delete. Think about creating an EC2 instance, creating an S3 bucket, creating an SQS queue. The data plane for an AWS service is the operation that provides the primary function of the service. For example, reading a bucket, or putting an object in a bucket, or running EC2 instance, or in Route 53 performing health checks, or responding to a DNS query. AWS resources, once provisioned, do not have dependency on the control plane. Data plane operations are statistically less likely to experience failure than control plane operations. Why am I saying all this? It's really, the reason for this is when you design your disaster recovery operations, you really should avoid using or having dependency on your control plane. We saw how AP modified their architecture to not use control plane operations for disaster recovery operations. Example of this, Route 53. Many of our global services have the control plane in a single region. Route 53, for example, has its control plane in the US East 1 region. However, data plane operations are actually spread across 5 different regions. So when there is an event in US East 1, you cannot actually create new update routing policies, but you will be able to run your health checks and perform DNS resolution. So you want to depend on those operations for disaster recovery and not on control plane operations or administrative actions when for your disaster recovery. Now, in addition to health checks and control plane, data plane, monitoring the health of your applications is critical. We saw the strategy used by AP, but there are really 3 common pillars of observability: metrics, logs, and traces. Metrics are data measured at various time intervals. Think about request rate, CPU percentage. Logs are discrete events. Think warning messages, error messages, state transformation. Traces is a user's journey through multiple applications. We have a lot of capabilities within AWS that help you implement deep monitoring within your application. So let's dive into some of those capabilities that you should look to implement. AWS observability tools really provide continuously monitoring for your infrastructure, for application and network level. A lot of these capabilities, let's go through each of them quickly, can be found in the AWS observability tool set. Container Insights allows you to collect, aggregate, and summarize metrics and logs from your containerized applications. X-Ray Insights analyzes your trace data and identifies any emergent issues that can happen in your applications. CloudWatch Lambda Insights, similar to Container Insights, specifically focused on your serverless applications using Lambda. So it collects, aggregates, summarizes system-level metrics like CPU, memory, etc. Contributor Insights, it lets you analyze your log data to create time series to display unique contributor data, such as top N contributors, unique number of contributors, etc. Metrics Explorer is the tag-based tool that allows you to filter and aggregate and visualize all your metrics across different types of AWS resources. CloudWatch Service Lens, it enables you to visualize and analyze the health, performance, and availability of all your applications in a single place. So it actually consolidates metrics, logs, traces for your services running on AWS. And CloudWatch Synthetics, which lets you create canaries, which are configurable scripts to monitor endpoints. You can see a lot of capabilities here. I want to touch on the principle of chaos engineering, which is basically a disciplined approach to identify failures before they become outages. Right? The concept of chaos engineering is not new. You take your workload, it's in a steady state. You give it an event, which is a hypothesis that will cause some disruption in the workload. You run the experiment, which is see how your workload reacts. If the workload maintains steady state, that's great. If it experiences some availability loss, you improve it, and that's the new steady state. So the principle of chaos engineering is not new. It's something Netflix has been doing for many years. But it's really important that you perform chaos engineering experiments on your workloads to test their resiliency constantly. You want to inject hardware failures, software failures. You also want to inject non-failure events such as traffic spiking. And this will really help you harden the workload and figure out areas that maybe you would not be able to test for resilience if you didn't run these experiments. I touched on only a couple of concepts here, like static stability, a control plane, and dashboards and chaos engineering. We have a plethora of information out there. So I would encourage you to store these QR codes and read up on other things such as graceful degradation, workload segmentation, automating CI/CD. So I spoke a lot about the important concepts in resilience. Let's walk through a number of AWS services that can actually help you build resilient workloads and implement some of these concepts and best practices for your workloads. AWS Resilience Hub. This is a central location for you to manage and improve the resilience posture of your workloads running on AWS. What Resilience Hub does is it enables you to define your resilience goals, such as RTO and RPO, your resilience posture, and actually implement recommendations for improvement based on well-architected framework. The Resilience Hub provides a central place with all AWS services and tools that you can basically use to continuously strengthen your resilience posture, right? And it really works well with other services, as you can see, with CloudFormation, System Manager, and so on, to provide recommendations so that you can manage your application resources. I spoke about the concept of chaos engineering, right? And mentioned how this is not something new. Netflix has been doing this forever. And they've spoken about it at reInvent. Because we at Amazon use it so extensively, this chaos engineering practice, and we find incredible value in it, we have a service called the AWS Fault Injection Service that helps make it easier for everybody to run chaos engineering experiments. What FIS provides is basically controls and guardrails that you can use to run experiments in maybe your lower or even production environments, and also implement controls such as automatic rollbacks or stopping the experiment if specific conditions are not met. It really provides a great framework to run controlled experiments that's repeatable across multiple types of workloads. So when you look at AWS Fault Injection Service, it gives you a great template where you decide what are your targets. These can be EC2 instances, EBS or RDS instances. You say what are the actions you want to perform, like shut down the EC2 instances, make the instance of RDS instance unavailable, or take out one cluster from the EKS cluster, and so on. And you can actually put stop conditions, so you can roll back or stop the experiment if you say things are going wrong or you want to just run the experiment for a certain amount of time. So what FIS is doing is giving you the ability to implement the principle of chaos engineering, but in a more controlled environment with some controls and guardrails. Amazon Application Recovery Controller. This service actually helps you prepare for and complete faster recovery for applications that are running on AWS. It provides two main capabilities. One is multi-AZ recovery. So that includes zonal shift as well as zonal auto shift. So it gives you the ability to shift traffic across multiple availability zones manually or automatically based on triggers and thresholds that you set. And so it really enables you to recover from single AZ impairments. It also provides capability for multi-region recovery, which includes routing control for failover and fadeback, as well as readiness checks for application monitoring. I look at Amazon Application Recovery Controller as that big red button you can hit, and it can fail over and fail back for your critical multi-region applications. I have not forgotten about my friends who are still running server-based workloads. In order to run server-based workloads and manage failover and disaster recovery, we have the AWS Elastic Disaster Recovery Service, or DRS. It's a pretty scalable, cost-effective service that minimizes your downtime and data loss by quickly recovering your servers on AWS in the event of a disruption. Over here, you can see on the left is a AWS primary region and a secondary region. There's basically a data replication agent that does block-level replication between your primary site and your secondary site in AWS. And you can actually fail over within a matter of minutes if there's ever a disruption. The cool thing with DRS, that primary site that you see is an AWS region can also be your data center. So you can use DRS for using AWS as a recovery site too. So pretty much with a click of a button, you can launch your recovery instances and your stack. I spoke about only few services. We have resilience, operation, design, and recovery capabilities across many services, as you can see. I want to tie it all back together. Chad mentioned they had a lot of challenges, but they looked at AWS best practices. I really want to call out challenges are specific but not novel. We can see how AP used some of our published best practices and known patterns and customize them for their specific needs, looking at control plane independence or chaos engineering testing or latency with data replication, as well as monitoring systems and region health. I want to come back to our 3 key takeaways before we let you go today. That is, app modernization innovation curve accelerates beyond lift and shift. We saw that in AP's journey. Multi-region requires careful evaluation and is not always the answer, and aggressively pursue simplicity. We saw how AP built such simple patterns to meet their data replication and tolerance needs. We want to leave you with some next steps. First and foremost, please read the latest headlines, breaking news, and videos at apnews.com. It is my trusted source of news. Highly recommend others to download the AP mobile app too. We also want to recommend some other sessions happening in the week that feature some nonprofit customer speakers. EarthScope Consortium will talk about using AWS for natural disaster recovery and earthquake early warnings on Wednesday. And on Thursday, Compassion International will be talking about the use of AWS for data governance. There's a QR code if you want to learn about the services. On the right-hand side here is the QR code if you want to get in touch with your account manager. If you already are in touch with them, and if you like some of the things that you heard today, please, they can help and get you connected with the right people. I'll bring Chad back on the stage, and thank you so much for your time.